So let's see if we can take what we just did and apply it to actually computing some of these importance scores, or coming up with a way to equate the importance scores to one another. So if we consider our graph again, let's just write down what we had before in terms of spreading the scores. We saw before this link would have been W over 2, this one also W over 2, Z, since there's 3 links, each one's Z over 3, Z over 3, and Z over 3. X gets X over 2 because there's 2 links. The out degree is 2. And Y gets just 1 because there's only one outgoing link, just Y. And this is a really good way to visualize it, by the way, because then you can see how each of them have to sum to 1, or how each of them have to sum up to the importance of the node. So this is W, again, this is X, this is Y, and this is Z. So each of the outgoing degrees sum to the incoming one. And so now, what you have to also realize is that we just said how each of these nodes spreads their importance scores. But now we can write each node's score in terms of the scores on its incoming links. So the idea behind PageRank is that we should be able to write each of these importance scores at node X in terms of what's coming into it. So that's going to define how important it is. Something coming from W, something coming from Z. And the exact values that we use are the W over 2 value here, because that's the importance that W spreads onto this link, and Z over 3, because that's the importance that Z spreads onto this link. So we just write an equation at each node in terms of the incoming links. So for X, we can get that X equals W over 2 plus Z over 3, right? Because if you start at W, the only way you can get to X is by either being on W or Z, if we're neglecting the idea of surfing randomly right now. And if you're on W, there's W over 2 chance then that you're going to come to X because it splits half and half. And if you're on Z, there's a Z over 3 chance you're going to come to X because it splits into thirds. Now let's try to write the equation for node W and W's importance score. You can only get to W in one step at least if you come from Z, right? So W then has to be equal to Z over 3 because when you're on Z, there's only a third of a chance of getting over to W. So we say that W is equal to Z over 3. Now we did W and X, let's do Y. Now Y has 3 incoming links. Okay, because we said before it has an in degree of 3, and that's why before at least we thought it was the most important node with the in degree. So you can get to Y if you're on W, X, or Z. So coming from W, there's half of a chance. So we say that Y equals W over 2, plus then coming from X, there's also half a chance, plus X over 2. Then coming from Z, there's a third of a chance. So we say plus Z over 3. And then now if we look at from Z's perspective, Z being the last node over here, from Z we can only get to it from either Y or X. So from Y it's actually guaranteed if you're following hyperlink, because the only Y's only out degree is only to Z. So Y only points to Z. So Z is equal to Y plus, and then from X it's half, so plus X over 2. So these equations right here, you can see that they're all dependent on each other. Right? X is dependent upon W, W is dependent upon Z, Z is dependent upon X in turn, Y is dependent upon W, X, and Z, and so on. And so this whole idea of X being dependent upon W, which is then dependent upon Z, which is then dependent upon X, and so on, is a circle. That's the idea of recursion. It's seemingly circular logic, but it turns out that we can actually solve, if we take all of these equations together, we can actually solve for one solution of the equations, guaranteed, provided that we make some assumptions about how the equations are built. We'll look at that too in a little bit. But if we can come up with a solution to these equations, that's going to give us the PageRank solution in each page's PageRank importance. So we have to come up with values of W, X, Y, and Z that will satisfy each of these equations at the same time. Now, when you solve a system of equations, there's 3 possibilities. The first possibility is that there's no solution. So there may not be values of X, W, Y, and Z that can solve each of these 4. We'll say 1, 2, 3, 4. There may not be values that can do it. The second is that there's a unique solution. And unique means that there's only one. So there's one unique way of doing it. We can find one value of w, x, y, and z at the same time that will work for all these. And the third one is that there's multiple solutions. So we'll write this multiple. So we want to make it so that we have a unique solution. And as we'll see, there is a unique solution to this set of equations, it turns out. But we're going to have to make a few modifications in the end of this, as we'll see, in order to guarantee that there's not either multiple solutions or no solution.